Okay, I've covered table C1 in maximum demand on domestic houses, single dwellings. This video is now going to cover what we call multiple dwellings, which could be blocks of units, townhouses, basically anything that moves more than two houses on each phase. So for example, in the first video I talked about that we could have one house per phase up to three. Then if we go to the fourth house, we must then go two units on one phase. So it'll be two on the red, one on the white, one on the blue. So depending on the number of units you get, you'll always divide them across the three phases. So if I've got 15 units, I'll divide it by 3, brings me down to 5 per phase. So for example, I would be in column 3, which would be 2 to 5 units per phase. So the other thing is, when we look at the units themselves as well, everything applied between A to H, all right? So what happens is H, moves into communal housing and stuff like that. But if we look at A to G, goes to basically domestic houses and stuff like that, and the same with the units. But once we get past G, we go into H, everything goes to communal. Once we're inside communal, we basically have to divide the loads up across the three phases. So if we're in a communal lighting or communal power points, everything, and I've got 60 power points, I need to divide it by 3, and that gives me an even number across the three phases. When we divide the units up by 3 and we apply them across A to G, right, so A to G, everything inside the unit, we're looking, they don't give us so much the number of points in like column 2. Column 3, 4 and 5 deal with a set number or set value, okay? We're not worried about the number of points, okay? It was only in column 2, they wanted to know the number of points. So for example, if I had 20 power points, it would be 3 amps for the first, 5 amps for the first one, and then 2 amps for each one after that. That was just an example, all right? Not so much quoted in the book. So when we get to columns 3 and 4 and 5, they don't care about number of points. So for example, if I've got 2 to 5 living units in lighting, they basically say 6 amps. It doesn't matter if I've got 5 units, it's just 6 amps. We go to the next one with next door to that, 6 to 20, it's 5 amps for the first, 5 amps for just a factor, which we just got to take into, and then it's 0.25 per living unit after that. So if I've got 5 units per phase, it'll be 0.25 times 5 plus my 5 amps. Okay, so the idea is to work down through the values and stuff like that. So what I'm going to do is just go through and point out a few things and stuff like that. So I'll just go down through some of the load groups and have a look. So like I said to you, in basically power points and lights, they allow for a factor in front. So for example, if it's so many units, they'll give you a value to times by, and then you have to add a value onto that end value. So for example, if I've got 2 amps per unit and I've got 5, it's 2 times 5 plus the 10% or 10 amps or 15 amps that I've allocated on the front part. We get down to GPOs on 15 amps. If we've got 15 amp GPOs, it doesn't matter how many we got, regardless of how many in a whole in all the units. We could have one in each unit. It's just a flat 10 amps. It's the same as what we did in column 2. They don't care how many we got. It's only a flat 10 amps. Same with the 20 amp outlets. It's only 15 amps for the 20 amp outlets. Doesn't matter if we got 10, 20, 30. It's the same thing as what we talked in about the earlier video. It doesn't change. Same thing too, if I have a 15 and a 20, they get added together. All the 15s come up to the 20 load group and they stay as one group as 15 amps, okay? All right, if we go into ranges and stuff like that, when we looked at column 2, it was 50% of the load, but now when they're talking about units, they go up basically 2 to 5 units. They're allowing 15 amps, that's it. You'll find between 2 to 5 living units, they'll just give you a set value. Once you move into columns 5 and 6, they'll start giving you a value per unit. All right. This one, number D, fixed space heating and air conditioning. I have a lot of problems with this one because students don't understand how to read it. It says 75% of connected load. Now, I've had all the experience with teaching this out on maximum demands and stuff like that, and I'll go through it, and the students, when it comes to the exam, they still make the same mistake. 75% of connected load. So what they'll do, if I've got a 9 kilowatt air conditioner or range, fixed space heating unit, they'll go 9 kilowatts times, divided by 230, might give them, say, 22 amps, and then I'll go times 0.75 and that's it. Well, the problem is, if I had 20 units, am I going to share that one that one heater between the 3 units? They don't multiply it by the times of the units. So the biggest thing I always say to my students in there where it says 75% of connected load, put in times units. Okay, it's a little simpler reminder, because what I get is I get this, 22 amps sitting there by itself times 0.75. Well, I'll tell you now, if you've got to times that by 15 or 20 units, mate, that's a lot of current that you've missed out on. All right, so that's a big flaw on that number D on all of those 3 items. 75% on 3, 4, and 5 can make a big difference. Instantaneous hot water services, well, they just give you a value per unit, very straightforward. The storage hot water service, which is basically a bulk storage hot water service, same thing, nothing changes. Air conditioning, spas and swimming pool heaters, that doesn't change from column 2 to column 5. All right, they just have 75% of the largest spa, 75% of the largest swimming pool pump, and 25% of the remaining. Doesn't change if it's a single dwelling or multiple dwellings. Okay. When we get into commercial load groups for lighting, communal lighting basically is full connected load. So if I've got 30 100-watt light fittings spread out across in the hallways and everywhere, so what I'll do with 30 of those is divided by 3. That'll give me 10 per phase, and then I'll times that by 100 and divide it by 230. One thing about power factor when you're looking at it on lighting as well with fluoros, power factor belongs to voltage. So if I've got anything to do with wattage will be on the top. So I equals P over V times power factor. Power factor is always tied to voltage. What happens is the power factor adjusts the value of voltage. So in other words, if I've got 0.7, it'll be 70% of 230 volts, which means it drops the voltage down, increases the current. Okay, so power factor, if you've got that with ballast or anything, is always tied to voltage. Okay, so the next thing we're going to is down to communal loads more than 10 amps. So if you have a look at that, we've got clothes dryers, water heaters, space washing machines and all that. They're in different, so you got 50%, 75%, and then 75% when you got spas and swimming pool heaters. It does change a little bit when they get communal appliances. Lifts also in K, that actually applies into column table C1 as well, into C2 as well, motors and other appliances. So look, very straightforward. The only thing I would suggest to be very careful of is, one I did leave out, 2 amps per point up to a maximum of 15. So if you've got 9 GPAs per phase, you times it by 2 amps, gives you 18. Well, the cutoff point is 15, regardless if you got more. So you do your working out, do 19, but then in brackets put 15 amps is your answer, okay? Because that's a cutoff point where we can't go any more. All right. I think I've covered all of that. If I can get some feedback if I've missed out on anything, it'd be great. Oh yeah, outdoor lighting too. There's no assessment for that, a purpose for maximum demand. So when you got outside living units and all that stuff, it just comes under load group A1. They don't take that into consideration because that comes down under communal lighting outside the unit. Okay, so when you look at a single dwelling, yes, it can have outside lighting up to 1,000 watts, but 3, 4, 5, it doesn't have any assessment because we're only looking at the lights inside the unit. The outside lighting becomes under communal lighting. All right.